An exponential function looks like this. Now, in exponential functions, the variable is the exponent. Up until now, we've had equations like x squared, where the variable was the base. Now, exponential functions, the variable is the exponent and the base is a constant. But here's the base has to be greater than 0 and cannot equal 1. Has to be positive, cannot equal 1. Because if it equaled 1, it'd just be a horizontal line. So let's say that A is equal to 2. So let's look at this graph, 2 to the power x. My domain, x can be anything from negative infinity to positive infinity. Well, when x is 0, anything to the power 0 is 1. When x is 1, 2 to the power 1 is 2. When x is 2, it's 4. It looks like this. There is no x-intercept. It can never equal 0. Now, when x is negative, 2 to the power negative 2 is equal to 1 over 2 squared. The negative exponent doesn't make the number negative, it makes it to a small number, makes it to a fraction. 2 to the power negative 10 is 1 over 2 to the 10th. So all the negative exponent does is makes you change where it is and drop the sign. That's why it's never a negative answer. So when x is negative 1, that means the graph is at 1/2. When x is negative 2, that means the graph is at 1/4. Because remember, if it's 2 to the power negative 2, that's 1 to the power 2 negative 2. And so that's the graph. Power of 7, right? 2 to the power 7 is 2 times 2 times 2, 7 times. Oh, okay. That's equals 128. So at 7, it'd go up 128. Well, if it's negative, it becomes a fraction. Because in the rule of things, if we had 3x to the power negative 2, this negative simply means change the location. Since it's on the bottom, move it on the top and drop the negative. That's all the negative exponent does. Doesn't make it negative or anything. It just changes the location of it. So we looked at, let's look at this one. Let's look at some of these values. When x is 2, what does that become? Yeah, becomes 1/4. So when x is two, I put a negative there. When x is 2, it's 1/4. When x is 1, it's 1/2. When x is 0, 1. Anything to the power 0 is 1. When x is negative 1, we have 1 to the power negative 1. The negative 1 simply means flip what's inside there. So it equals 2. When x is negative 2, we have 1 over 2 to the power negative 2. Flip that and drop the negative. So it becomes 4. So now it looks like this. So what does this just show you? My base, if the base is greater than 1, it's an increasing function. If the base is between 0 and 1, it's decreasing. Right. How about this one? Now, example 3. Now we have transformations. Graph this one. That is an exponent. How does it relate to the original function of 2 to the power x? 2 to the power x looks like this, and it crosses at 1. Nope. It's a horizontal shift. Whenever you affect x first, it's a horizontal shift. So what this does, remember, when x was 0, it equaled 1. When would the top equal 0? When x is what? X minus 2. What would x have to be to make this equal 0? 2. 2. X minus 2 equals 0. No, 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 no. You're losing track. We want to relate, we know what this graph looks like. 2 to the power x is this graph. When x is 0, it equals 1. Because 2 to the power 0 is 1. Anything to the power 0 is 1. So now this one, how do I make my top equal 0? When x is 2. So at this point, when x is 2, it equals 1. 2 minus 2 is 0, so the function equals 1. So the graph looks like this. We're going to have to trudge along. Number 2, y equals 2x minus 4. What happens here with respect to transformations? Why? It's 2x minus 4. It's not 2x. This is not an exponent. This is part of the equation. It's 2x minus 4. So the original one was 2x. 2 to the power x. So now the whole graph goes down 4 spaces. 1, 2, 3, 4. So my intercept is now down here, which means one below my intercept is the bottom line, is my asymptote. So the graph looks like this. And this one's going to cross it too. Yes. Or we can have y equals 5 minus 0.5x. What is 0.5 in fractions? So this is 1/2 to the power x. So let's draw this graph first. What does the 1/2 x graph look like? Is it increasing or decreasing? It's decreasing. We just talked about it 5 seconds ago. It should be in your notes right in front of you. When x is between 0, when a is between 0 and 1, it's decreasing. Now I switched the sign in front of it. What does that do? So when x is 0, I get 1. Then I put a negative in front of it, makes it -1. So now that one does, what this negative does, it flips across the x-axis. We have to build to it. That's what transformation is all about. You can't do it all at one time. You first start off with what you have. This is a decreasing function. When you change the sign in front of it, it changes across the x-axis. Now, this is a +5. What I do, whatever this number is, I add 5. 1, 2, 3, 4, 5. So there's my new intercept. The graph crossed like this. And always between the y-intercept and the axis, it's always 1. So since my x-intercept, my y-intercept was down here at -1, because I flipped it, I raise it 5. So -1 to 0 to 1, 2, 3, 4. So that's my new x-intercept, my new y-intercept. So the graph doesn't touch that horizontal asymptote. The horizontal asymptote is always 1 away from the vertex, or from the intercept. You're just trying to go too quick, because you can't do it that way. Yeah, this will be our last one, our last section. We'll meet after the break. This is compound interest. For compound interest, we use this formula. What is compound interest? Compound interest is what like credit cards do. Each month they add on more interest to how much you borrowed. Instead of a simple interest is you borrowed $100. I don't care when you pay me back $100. That's simple interest. No interest. Compound interest is it changes each week, each month, each day, each year, however long you say it. A is called an annuity. Amount that is due or owed. That's how much money it's worth. P is the principal. That's the amount borrowed. R is the rate in percent converted to decimals of the note. It's always a decimal. N is the number of times in a year you compound the note, the interest. So N could be, if it's monthly, it's 12. If it's yearly, it's 1. If it's weekly, it's 52. If it's daily, it's 365. So that's what N stands for. T is the number of years you borrow the money. That's what the T is. So example 4 says $100,000 is invested at 6.5% interest. Compounded semi-annually. Okay. Write the formula for T years. So the annuity, what's my principal? What's my P? $100,000. That's how much you have. It's always money. It's always the dollars. 1 plus, what's my rate? What's my R? R is 6.5%. You have to convert it to decimals, so it's 0.065. Move the decimal 2 to the left. So it's 0.065. N, how many times do I compound it? Semi-annually. That's twice a year. Semi means half. Right. So it's N was 2 times T. So there's your formula. Depending on how long you keep the money, then you can calculate it. Well, of course you do 0.065 divided by 2, add 1, then let's say T equals 5 for 5 years. $100,000. 1 plus 0.65 divided by 2, 2 times 5, which is equal to 10. So you do first do inside the parentheses. Let's say that equals, for simplicity purposes, let's say it equals 0.5 to the power 10. You do this next. On your calculator, you would have open parenthesis 0.5. Let's just do it completely and clear everything. So we have 0.065 divided by 2 plus 1 equals that. Take that number and then raise it to the power 10. 1.4. Yeah, but I'm working the whole thing out. So I'm sorry, I don't have it on the screen. I should, yeah. So what I've just done so far is I've just done this part. 0.65 divided by 2 plus 1 to the power 10. That is equal to something like 1.378689. Now I multiply it by 100,000. $137.6. If you're investing at it and it's an interest of 6.5%, which is unheard of. In 5 years, you'd have that much money. Now imagine if it was in the hundreds of millions, Now you see why the rich get richer and the poor get poorer. Which is why everybody, I try to tell my students, start investing now. You don't have to invest big. Start $10, $100, and just do it each month. At the end of, if you do it each month, $10 a month, you invested $120 plus whatever interest you got. So that's only 1 year. 10 years, that's 1,200 plus whatever interest you got, and it compounds from there. If everything works out, yeah, and that's why people do it really safe. Using the same equation, we came up with a number called E. E is a constant value of, what's it, 2.71828, blah, blah, blah. And it's based on this annuity formula. Because if you borrowed $1 at 1%, 100% for 1 year, and well, you keep on changing the time. Eventually, that number is going to keep on going, adding up to 2.718. So we just call that E. It's called Euler's number. Euler's. EUL. Euler. So since it is a number, it's a constant. E to the 0 power is what? 1. Anything to the 0 power is 1. E to the 5th power. Well, if you look at every calculator, you will see somewhere there you have an E function. Yeah, the exponential factor. Right here. E is 2.718. Take that number and look for the equation x to the power y, and I'm going to say I want y to be 5. So that number is 148.413, so on and so forth. If I do it this way, to negative 0.025. So I have e to the power negative point, no. I have e to the power, open parenthesis, negative 0.25, close parenthesis. It'll give me 1.97303. So you see what's happening. If it's a positive integer or number, it gets bigger because 2 to the power. If it's a negative, it gets smaller. So look at the graphs. That's the last thing we're going to do here today. Graph. E to the x and e to the power negative x. What would e to the x look like? No, there's not one. It's a graph. It's got infinite number of points. Well, what is e? Is it between 0 and 1, or is it greater than 1? It's greater than 1, so the graph looks like this. Crosses at 1. If this now is, since the exponent is negative, What we have here is 1 over e to the x. It's a decreasing function. E to the power x plus 3. What would that graph look like? Which direction? Up, down, left, right? No. This is, you affect the value of x first. You're not touching the value of the function yet. This is inside the function. So it's a horizontal shift, 3 to the left. Because at e to the x, when e is 0, we know it's 1. What would this have to be 0? -3. So it's 1. So it'd look like this. E to the power negative 0.5x. Well, we know, first off, we know that it's a negative 1/2 x. The exponent is a fraction. And since it's negative, we flip it across the y-axis. Remember, go back to review your chapter 2 of transformations. If you're changing the value of x from positive to negative, it flips across the y-axis. If you change the function from positive to negative, it flips across the x-axis. So all this one does, simply because it's negative. Right. The reason being because let's say we have the function f of x equals x. With let's just say 2x plus 3. That's a line like this. But 2 minus x plus 3. I've made a shift. 2 to the right. So my graph will look something like this. But since x is negative, I now flip across the y-axis. Again, review your chapter 2 notes for transformations. Typically, I try to do 2 and 3 together at the same time.